actually decided to talk about two things that are very near and dear to my heart. I really like storytelling, and I'm also very fascinated by how math plays out in social contexts, which always led me to look at dating apps and how they recommend people to us and how different dating apps works. So I decided to talk today about modeling and storytelling and what Tinder can teach us about objective functions. So I unfortunately, because it seems like there are a lot of questions, I will not be talking about heuristics or ways you can solve very difficult problems. I will mainly be focusing on what our choice of an objective function can tell us. What narrative does it say? Does it tell? So I'll be using dating apps and specifically Tinder to explore how these choices usually can reflect values, they can reflect priorities, and the world we're trying to model. So let's dive in. Sorry. Yeah. So the main idea of this presentation is that in optimization, it's all about storytelling, and modeling is all about storytelling. So every time we define an objective, we're making a statement, right? So in the case of dating apps, the objective function will shape user experiences very heavily. Is the app optimizing for engagement? Is it optimizing for quality? Is it optimizing for conversations? And then obviously every one of these objectives would lead to a completely different user experiences. So we would think that if the objective is to maximize swipes on the app, then the recommender would show you conventionally attractive people, or people that you are likely to swipe right on, regardless of whether there's reciprocity or not. If the objective is to maximize matches, then in this case, it would make more sense for the recommender to show you users that are interested in you, just to increase the likelihood of the two users matching. And then if you want to maximize for conversations, then it gets a bit trickier, because then we have to look at compatibility. Maybe one thing I assumed everyone is familiar with Tinder and how it works, but the main idea is you see profiles, and then for every profile, you can either swipe right if you're interested or left if you're not interested. Sorry. So speaking of having talked about Tinder, there's also another contender that I always found very interesting in the way they market themselves, which is Hinge. So their slogan is, "It's an app designed to be deleted," which, based on the sentence, you would expect that you meet someone in the app that you like enough that you wouldn't think you need the app anymore and you can delete it. And for me, this was very interesting to look at from an optimization point of view, because in this case, recommendations are very heavily shaped by quality signals. So in this case, the recommender is not really trying to push a stack on you that you will engage so much with, as much as a stack that you will have mutual interest with, mutual likes with. In this case, I'm sorry. In this case, the stack that you are shown is very heavily influenced by this objective function of how compatible can these two users be. And then, for me, this was also an interesting, let's say, additional layer that they added. It's not really related to modeling, but I thought it would be cool to incorporate it, which is when there were too many options for users, Hinge decided to include a UX fix, which was you had turn limits. So essentially, it was a constraint that was imposed, but on users, not on the recommender, that basically limited the amount of ongoing chats you can have, pushing the let's say success of conversations, or leading to real life dates, because people, just like models, behaved in a very a similar way. So if they were constrained with the amount of people, the amount of users they can engage with, then they had to make better decisions. And ultimately also work towards the same goal that the objective function is working towards, which is meeting someone, having and deleting the app. This brings us to actually, in modeling, a very subtle but important mistake that happens often, and I still fall in it very often, which is sometimes treating flexible goals as hard constraints. So, for example, I mean, my background is mostly in routing, and one common thing I always heard is that deliveries must be on time. Okay, yes, deliveries must be on time, and it sounds like a constraint, like a hard constraint, like it must happen. But in reality, sometimes it makes more sense to model this constraint as the goal, as the objective. So we go back to our objective function and we realize it's not that we want to minimize the distances or we want to minimize.
Hey, Tanner, can you go back to Surrey channel?
Can I go back to what?
Go for surveying.
Okay, Charles, I'm muting you. Yes. So I was saying, in reality, very often, some constraints that we think are hard constraints can be a goal. And instead of saying our deliveries must be exactly on time, in reality, we just want to minimize how late we are or how late the truck or the delivery is from this imposed time. And if we treat it as an objective instead of a constraint, let's say minimize lateness, minimize on time, maximize on time rate, then we start pushing the model to have, or giving the model some room to work with trade-offs, which for me, this is a very powerful tool in modeling. The same problem, you can look at it from two different perspectives and eventually get to the story that your user is asking for. So now, back to dating apps. While I love talking about routing, I think dating apps are a lot more interesting. And I thought we could just have a very quick back and forth, maybe in the middle of my mini presentation, which is if we are the ones designing an objective function for a dating app. So we want to decide the stack that the user will see, which are basically other profiles. We have some inputs. We have whether our decision variable is whether user I is going to see user J. And we have other data that some of them is pre-calculated, some of them is an input from the user, so predicted compatibility score between user I and user J, predicted general interest level of user J, so how likely are people to swipe on them, regardless of compatibility. We have a set of hard constraints, so I call them DB as deal breakers. So on most apps, you are able to say, for me, I don't want someone who's living far. I don't want someone who's older. I don't want someone who has this political stance, and you're able to impose these constraints. But you're also able to add some of your interests. So for every user, we have a collection of interests or traits exhibited by them. And then the challenge would be is how would we model this objective function? Do we want to, how can you maximize meaningful matches? And in storytelling, we have to answer what are meaningful matches. I have some ways that I have added, but if someone would like to contribute a bit in the middle of my presentation, please go ahead. Then, okay, then I'll keep going. There are obviously many ways that we can model this objective of having meaningful matches, because meaningful matches, they can just be good quality for the user. They can mean having more swipes, and they can also mean just having a potential interest between the two users. So if we just want to maximize for quality matches, in this case, we would just look, okay, how compatible are these two users? Obviously, under the profile viewing limit, under having active users, respecting the preferences of the preferences imposed by user I. If you want to optimize for swipes, so from a business perspective, meaningful matches are just a lot of matches. In this case, we would be maximizing the likeness of users that are shown. And then finally, for me, this was the model C, which is what related the most to actually constraints being an objective rather than, or let's say requirements being an objective rather than a hard constraint, which is maybe we don't want to maximize for predicted compatibility. Maybe we want to minimize the intersection between deal breakers and traits. So I want to show you as many people that you could like. I don't know if you're going to like them, but I know for sure you're not going to not like them. Again, we see that the choice of objective function, it shapes the experience in a very different way. It shapes the story in a very different way. And in the case of Tinder, Tinder actually optimizes for engagement. So it calculates a swipe probability, and this is what their objective function is trying to maximize, is how many swipes can you do. And obviously they would introduce other features that can boost this predicted swipe probability, right? So smart photos, super likes, and the result is high engagement, exactly the story they want, exactly the goal they were going for, is just users engaging very much with the app regardless of the outcome. And then just for final takeaways, I would say is, of course, especially in social contexts, every objective would carries a bias. In some cases, it's just a bias in some cases, it allows users to develop addictive, let's say, addictive patterns, especially when we're optimizing for engagement. And then, obviously, in social contexts, it always highlights one truth and hides another. So if the truth is that we want good quality matches, then it's very possible, and by good quality matches, let's say many matches, then then the focus is actually on just high engagement, high probability of swipes, and rather not actual compatibility or intersection of interests of two users. So takes us back to the question, is what we're optimizing for, is it a goal or a guardrail? Do we want to get people to talk, or is it a necessary requirement? Is it a hard constraint for people to match, or it's just there and we want to increase engagement? So that's it. Thank you for listening to me talk a lot about dating apps. Like I said, it's a topic that I find very interesting, and I think optimization and matching algorithms play a very big role in it. Yeah, thank you for listening.